This will be part 3 of the final review, going over the geometry section. So the hour hand of a clock moves from 12 to 10. Through how many degrees does it move? If you think about a clock, from 12 to 6, altogether a full circle would be 360 degrees. If you imagine just going halfway, half a circle is 180 degrees. So let's just say going from 12 to 6, that means you went 6 hours. So 180 degrees divided by 6 hours, 180 divided by 6, that'd be 30. So that means you go 30 degrees for every hour. From 12 to 10 is going to be 10 hours. So that is 10 times 30, or 300 degrees. Find the measure of angle 1, 2, and 3. A couple things you want to remember is that any time that you can make a half circle, that's going to be 180 degrees altogether. And that this symbol right here means that's 90 degrees. So right now I know this is 90. If I were to combine, say, these three, 58, 90, and angle 3, that one should add up to 180 degrees. I can also see that this is a 90 degree angle, then from here to here would be 180. So these two must be 90 degrees. And if this part's 58, then that means angle 1 would have to be 32 degrees. So 32 and 58 adds up to 90. And again, a couple of things I know, vertical angles, so I know this is 90, but if I add these three up, 58 and 32 is 90, and this must also be 90 degrees to add up to 180. And then if this is 90 and 32, that would be 122 degrees. So that means that this would have to be 58 degrees. I also know, again, see vertical angles are equal. And then 90 and 58 would be 148. So this must be 32 degrees then to, again, vertical angles, but also to add up to 180. And if I were to add these three up, 58, 32, that's 90. 90, 90 is also 180. So angle 1 is 32 degrees, angle 2 is 90 degrees, and angle 3 is 32 degrees. Figure shows two parallel lines cut by transversal. One thing you want to remember is there's these certain angle pair relationships. One, you have vertical angles are equal to each other, so angle 5 is equal to angle 7. Angle 6 is equal to this one, 17 degrees. Angle 4 and angle 2 are equal. And angle 1 and angle 3 are equal. So this is just the vertical angles. Those are equal to each other. You have alternate interior angles. So alternate sides, and on the interior, these parallel lines. So angle 1 is equal to angle 5. And angle 4 is equal to 17 degrees in this case. You have alternate exterior angles are equal. So angle 7 and angle 3 would be equal to each other, and angle 2 and angle 6 would be equal to each other. You also have consecutive interior angles or supplementary. So 17 and 1, angle 1 should add up to 180 degrees. Also, you have the fact that you have all these half circles that you can make that add up to 180 as well. So if we go ahead and just kind of do this, it says find the measure of angle 3. So there's a couple ways we could do this. One way I might do this is that I know that angle 7 and 17 should add up to 180. So this would have to be 163 degrees. And then by alternate exterior angles are equal. So since this is 163, this also would have to be 163 degrees. Use an algebraic equation to find the measure of each angle that is represented in the terms of x and show your work. So I know that these two angles combine, this angle right here and this angle right here, if I add those two up, combine them, it equals 90 degrees.
Tyler Schuler to the main office. Mr. Shank, Mr. Shank, could you come to the main office, please, Mr. Shank?
So if I do my 12x minus 3 plus the 3x plus 18, If I add these two angles up, it should equal 90 degrees. And now I just need to be careful of my like terms. I've got 12x here and a 3x here. I've got minus 3 and plus 18 there. So 12x and 3x is 15x. Minus 3 and 18 is 15 equals 90. Subtract 15 on both sides. You get 15x equals 75. Divide both sides by 15, you get x equals 5. This is not the measure of each angle, though. This is just what x is equal. So I need to go back, plug it in. 3 times 5 is 15. 15 plus 18 is going to be 33 degrees. So that's one of my angles. 5 times 12 would be 60. 60 minus 3 is 57, and that's my other angle. Notice how 33 and 57 adds up to 90. Using an algebraic equation, find the measure of each angle represented. Show work. Again, these are two parallel lines. I know they're parallel because this is my symbol for parallel lines. So alternate interior angles are equal, so I can set these two angles or these two equations equal to each other. So 5x minus 16 is going to be equal to 4x plus 2. Get x's on one side. So subtract 4x on both sides. You're left with x minus 16 equals 2. Add 16 to both sides. You get x equals 18. And again, I have to go back and plug it in. So 4 times 18 would be 72. 72 plus 2 is 74 degrees. 18 times 5 would be 90. Yes, 90. 90 minus 16 would give me 74. So again, they're equal to each other, so that's right. Find the measure of angles 1, 2, and 3. So I have parallel lines, so all those rules, those angle relationships are in play, and then adding up to 180 degrees and vertical angles are also in play. So right now I kind of see I can form a half circle by combining this 90, 44, and angle 3. So I'm going to go ahead and do that. 90 and 44, that gives me 134. And I know if I add that with angle 3, it should equal to 180. So angle 3 is going to be equal to 46 degrees. And now if I combine these three, 46 and 44 is going to be 90 degrees. So angle 1 must be 90 degrees, and I can see by vertical angles that that would be 90. And then angle 2, let's see, I know that if I kind of break this thing apart, what could be helpful? This is on the exterior here. So I know a couple things. One, I know corresponding angles. So corresponding angles are equal. So like this angle right here, angle 2, that would be the same as this whole angle right here. It's in that bottom right position of these two lines. So if I imagine here's two lines, here's my transversal, here's angle 2 down here. It's in that bottom right position of this thing, which is what that 90 and 44 is. So it should be 133. But maybe I don't quite see that. Maybe I know, okay, that's on the outside, so I know alternate interior angles are equal. So if I could figure out this angle, I could be in good shape. And again, that's going to be 90 and say the 44 right here. So that would again add up to 133. So a couple ways you could do that. Other options are, you could say, okay, if I know that angle 1 was, let's see, 90. 90 and 44 is 134. So this would have to be 46 degrees, again by vertical angles, or just adding it all up to 180. Alternate interior angles means that this has to be 46 degrees. And then if I do 146 and that should be 134. I messed up. This should have been 134 degrees if I add up 90 and 44. Use an algebraic equation to find the measure of two angles described. The measure of an angle is 4 times greater than its complement. So if I have two angles together, or if I have one angle, angle 1, its complement. So if I say angle 2, and angle 2 is angle 1's complement, It's the angle that when I add it to angle 1, it's going to equal 90 degrees. So two angles are complements is when you add them up equals 90. So like if I knew angle 1 was 50, angle 2 must be 40 degrees because that's what would make it 90. If angle 1 happened to be 30 degrees, then angle 2 would be 60 degrees. It's going to be whatever it is. If I add these two things up, it will make it 90 degrees. So it says that the measure of the angle is 4 times bigger than its complement. So whatever this angle is, if I call it x, it's going to be 4 times an angle 2, so let's call that y. It's just a different angle. If x is like your angle, it's going to be 4 times greater than this thing, which is, just call it your complements. If I call this one the complement, the thing that I add that's going to make it 90 degrees, that x is going to be equal to 4 times this thing's size. So since I know x is 4y, I can replace it in my equation. I get 5y equals 90, or solve for y. Y would be then 14 after you divide by 5. 18 actually. Now that I know that y is 18 degrees, x is 4 times y, so 4 times 18 would be 72. So 18 and 72. So the angle is 72, its complement is 18, what adds up to 90, and 72 is 4 times as big as its complement is 18. How high on a building will a 15-foot ladder touch if the foot of the ladder is 5 feet from the building? Make sure that you are drawing pictures whenever you get these types of questions. So you have a building, you have a 15-foot ladder, and it's 5 feet away from the mark. How tall is the building? Since this is going to be a right angle, you can use your Pythagorean theorem. The Pythagorean theorem says that if you have two legs, if you take, say, this leg, we'll call it, actually, it's called A, B, and C, that the two legs squared is going to equal the longest leg, the hypotenuse squared. So 5 squared plus x squared is going to equal 15 squared. So this is going to be 25 plus x squared equals 225. Subtract 25 from both sides, you get x squared equals 200. To get rid of a square, you're going to take a square root. And while you do get two solutions, a plus and negative version of this, you're going to take the positive version because you're talking about a real world ladder here of building height. So x would be equal to the square root of 200. If you simplify this as much as possible, square root of 200 you could break down as, say, 20 and 10, 4 and 5, 2 and 2, 5 and 2. So you have a pair of 5s, a pair of 2s, 2 left over, so that would be 10 square root 2. So you could either put square root of 200, or if you simplified it like you should, 10 square root 2. An Olympic swimming pool, so pool looks like that, has length 50 and width 25. What is the diagonal? So again, you have a 90-degree angle here, and again, the two legs squared is going to equal the hypotenuse squared. 25 times 25 should be 625. 50 squared is 2500. X squared would be equal to 3125. And this you'd have to do on a calculator, because I'm not sure. But again, make sure you're not squaring your answer, doing 3125 squared, and your answer should be something, it's going to be bigger than 50, because 50, your x is the longest side, so if you're something bigger than 50, but not so much bigger that it doesn't make sense. So 3125, and then the square root. Do we have the square root button? Square root. So 55.9. X equals 55.9. One angle of a triangle is 5 times as large as another. The measure of the third angle is 40 degrees greater than that of the small angle. Find the measure of each angle. Well, here's the thing. I know in the 3 angles of a triangle, they add up to 180 degrees. So let's see if I can work with this a little bit. So one angle of a triangle is 5 times as large as the other. And the measure of the third angle is 40 degrees greater than that of the smallest angle. Okay, so we have, let's say, 3 angles. We have small, medium, and maybe the largest one. So one angle of a triangle is 5 times as large as another. And the measure of the third angle is 40 degrees greater than the smallest one. So let's see, large is equal to, or the third angle is equal to, let's say, 40 degrees plus the smallest one. And then you have, let's say, the first angle, which is just the smallest one. And then you have one angle triangles 5 times as large as the other one. So let's see, 5 times. So I'm guessing that must mean that the medium one is 5 times the smaller one. I'm not sure. I'll come back to this one. That one's weird, kind of weird for me right now. Let's see. Find the measure of angle 5 in the picture below. So we have 30 degrees, 90 degrees, that's 120, so this must be 60 degrees. If this is 60, that's 120. If that's 60, then this is 60. Vertical angles or a half circle, same thing here, that must be 120. And then 70 and 60 is 130, so 130 and 50 should add up. They also have this theorem that says if you add up these two remote angles, they're equal to that exterior one. And this one, let's see, we can start doing a half circle. That's 112 degrees. I'm told that these things are parallel lines, so I have my alternate interior, alternate exterior angles. So if this is 68 degrees, angle B must be 68 degrees. And since these two things are telling me that these are equal, this must be also equal to 68 degrees. And then since I know that this whole thing should add up to 180, 68 and 68 would be 136. 136 minus 180 would be 46. And if I notice 46 and 68 adds up to 112, which is also what this is, alternate interior. If I add these two angles, should equal that 112. So I've got a few things going. 68 and 68 in this triangle, so that's 136, so that means 136, this must be 46 degrees. And then 46 to get to 180, that must be 134. And then if this is 134, this must be 46 degrees. Because this is a isosceles triangle, these two sides are equals. Angle F and angle G must be equal to each other. So 180 minus 46 gets you 134. You cut that in half to make it even. That must be 67. So this is 67 and 67. If that's 67, that means that this must be 113 degrees. Because there's 4 angles in here, 4 angles is going to add up to 360 degrees. So let's see, 46 and 134, that's 180, plus 113, that's going to be 392, so 360 minus 293, that would end up being 67 degrees, I believe. And then let's see, 67 degrees. What else can we do? This is 113. If this is 113, this has to be 67. Vertical will make it to 180. I know that these two sides are equal, so these two angles must be equal to each other. So let's see. Is there anything else we could do to help us out? Anything else that would be interesting? Let's actually say, so alternate interior, I know that those would have to add up to 113. That's not going to be super interesting, so that's not going to be helpful really. Let's see, I know this would be 113. This would have to be 67. Okay, so I have to use the fact that this is isosceles. So these two things are going to be equal. So if I have 67, let's see, which one is it telling me these are equal? So 113. No, that's not quite right. What am I doing wrong? What am I missing? Okay, so I see my mistake. 68 and 68 is 136. So that means that this would actually be 44 degrees. This would be 44 degrees. This would be 136. This would make this thing 44 degrees, which would make this thing 136. So that's going to be 68 degrees each, which makes this thing 112, which makes this thing 68, which makes this thing 68, which means that you have 112 degrees left over. Split that into two, that's going to be 56, and 56, and 56. And then your 180, this would be 124, and then this would also, let's add up to 68 and 56, that is 124. Yes, 124, so this would be 56. Double check. 56, 56, 68. Yes, 180. Okay. Okay. Should have been all those angles. And that's it.